So friend, this is our third lecture on the topic limit of function. Now in previous lecture, we have solved some example that how to find out the limit of function in two variable. Now let us take some more example. So write down the example. So write down example. Evaluate limit xy tends to 0, 0 of the function x square y divided by x raised to 4 plus y square. Now up till now, we have solved 5 to 6 example on limit of function, to how to find out limit of function in two variable. So I am going to explain again to how to find out the limit of function. Now what is the method for finding the limit? We have to consider some different equation. Consider suppose limit along x-axis. Equation of x-axis is, that is, y equal to 0. Now first of all, consider this equation. Suppose we may consider the equation of y-axis. The equation of y-axis is, that is, x equal to 0. Now in this method, how to solve the limit of function? We are going to use some number of equations. We may use the equation suppose y equal to x. We can take the equation y equal to x square. We can take the equation y cube equal to x square. Or we can take the equation suppose y raised to 4 equal to mx square and so on. So see, we can take some number of equation, and what is the condition? We get or we want some different limit. What is the condition or how to solve the limit of function? Take some different equation and get some different limit. Now suppose, if we consider suppose limit along x-axis, if this is 0, then find out the next path. Now suppose, let us take the limit along suppose y-axis. Now suppose limit along y-axis, if this is some different value, suppose it is 1. If limit along x-axis, if it is 0, limit along y-axis, if it is 1, so we can conclude that limits are different along two different paths. This is called limit does not exist. How to show the limit does not exist? This is the technique for showing the limit does not exist. What is the method? Use some different equation. Just use the simple equation. You can take any number of equation. So just take the simple equation, x-axis, y-axis. These are some simple equation. So use simple equation and get some different values. That is called limit does not exist. So write down the solution. So this is our solution. Consider limit along x-axis. And what is the equation of x-axis? Equation of x-axis is y equal to 0. So write down, that is y equal to 0. So what we are using? We are using some different equations. So this is our first equation, y equal to 0. So find out this limit. So write down, therefore we get, so what we get? Put y equal to 0 in the given function. So this is limit x tends to 0. Now put y is equal to 0, x square into 0 divided by x raised to 4 plus 0. So anything into 0, we can directly write here 0. Now let us take some more equation. Now consider second equation as y-axis. So write down, consider limit along y-axis. And what is the equation of y-axis? Equation of y-axis, we know this, okay, x equal to 0, that is the equation of y-axis. So write down, that is x equal to 0. So now find out this limit along this second path y-axis. So now put x equal to 0, therefore we get limit y tends to 0. Now put x equal to 0, this is 0 into y divided by 0 plus y square. So obviously it is again 0. So see what we get. We have taken first of all the equation of x-axis. We have found this limit along x-axis and we have found this limit as 0. What is the next step? Consider any other equation. Now this is our second equation. Consider the limit along y-axis and we have found this is again 0. Now what is the third step? Okay, find out some concrete root. Find out some concrete root and let us get some different limit. If the limits are different, we require other than 0 number, because the limit along x-axis it is 0, as well as we have found limit along y-axis is again 0. Now we require some different values other than 0. So find out third root and get some different limit. It is called limit does not exist. Now see how to get this third root. Now see how to get third path. Now find out the maximum power for x in denominator. What is the maximum power for x in denominator? 4 is the maximum power. X raised to 4, it is the maximum power for x in denominator. So adjust this x raised to 4 in numerator. See what is the technique for finding the limit, or how to select the third limit. X raised to 4, it is the maximum power. So adjust this x raised to 4 in numerator. Now already there is x square, that means we have to take this y equal to x square. If we take y equal to x square, then x square into x square, it will be x raised to 4. So this is the standard technique for selecting the path. How to select the path? First of all, find out the maximum power for x in denominator. What is the starting? First of all, see what is the maximum power for x in denominator. X raised to 4, it is the maximum power. So adjust this x raised to 4 in numerator. That means we have to take y equal to x square, or we can take y equal to mx square also. So consider this path. So write down, consider the limit along the third path. This is our third path. We take this path as y equal to x square, or we can take mx square also. We can use both the path. Either we can take y equal to x square, or we can take y equal to mx square also. So write down, therefore we get limit x tends to 0. Now if we take suppose y equal to x square, then this is x square into x square divided by x raised to 4 plus y square. Y square means this is x raised to 4. Now suppose if we take suppose y equal to mx square, if we take this path, then what is our calculation? Our calculation is like this, limit x tends to 0. If we consider the limit along the path y equal to mx square, then this is our calculation. Limit x tends to 0, this is x square into, now put y is equal to mx square divided by x raised to 4 plus y square. Y square means this is m square into x raised to 4. So simplify this limit. This is limit x tends to 0. Now x square into x square, this is x raised to 4. X raised to 4 plus x raised to 4, this is 2x4. X raised to 4, x raised to 4, it get cancelled. So this is our 1/2. Now if we take suppose y equal to mx square, then this is our calculation. This limit x tends to 0. X square into x square, so this is mx raised to 4 divided by x raised to 4 plus m square into x raised to 4. So cancel x raised to 4 throughout, so this is limit x tends to 0. Now cancel x raised to 4 throughout, this is m upon 1 plus m square. Now what is this m? M, it is some constant quantity. M equal to 1, 2, 3, 4. This is some constant quantity. So limit of constant, it is same. So this is m divided by 1 plus m square. Limit of constant number, it is same. It is m upon 1 plus m square. So see, if we consider the limit along y equal to x square, then this is our calculation. If we consider y equal to mx square, then this is our calculation. What is the limit? M upon 1 plus m square. Now see, we have found limit along first path, it is 0. We have found limit along second path, it is again 0. Now if we consider limit along third path y equal to x square, then we got this limit as 1/2. So we can say that the limits are different along two different paths. It is called limit does not exist. How to show the limit does not exist? Consider some different equation and get some different limit. It is called limit does not exist. So write down therefore limits along different paths are different. So write down therefore limit does not exist. Now see, if we consider or if we use this path y equal to mx square, then we have found this limit as m upon 1 plus m square. Now what is this m? M, it is some constant number. Now suppose if we put m equal to 1, then what we get? We get limit equal to suppose 1/2. If we take suppose m equal to 1, then what is this limit? This is 1/2. If we take suppose m equal to 2, then this limit will be 2/5. If we put m equal to 3, then this limit will be 3 upon 9 plus 1, this is 10 and so on. So see what is our observation for different values of m. If we put m equal to 1, then we get some limit. If we put suppose m equal to 2, then we get some different limit. If we take m equal to 3, then again we get some different limit. So what is our conclusion? For different values of m, we get different limit. So limits are different. This means that limit does not exist. So write down here, therefore for different values of m, we get different limit. So write down therefore limit does not exist. So see, I have given you two different methods for finding the limit. Either you can write this solution or we can write this solution. What is the solution? First of all, find out limit along x-axis. Find out limit along y-axis. If they are equal, then find out third root and get some different answer. Write down next example. Write down next example. solve limit xy tends to 0, 0, x square y raised to 4 divided by x square plus y raised to 4 bracket square. Now again we have to find out, or we have to solve this limit. So what is the process? Consider some different equation. You can use number of equation. Consider some different equation and get some different limit. If suppose limit along first path, if this is 0, consider next equation. If suppose this is again 0, consider third equation. If suppose this is again 0, find out fourth equation and get some different value. So what is the process? Consider some different paths and find out some different limit. It is called limit does not exist. So write down first path, write down solution. So this is our solution. Consider the limit along first path, which is x-axis. So consider limit along x-axis, and what is the equation of x-axis right here? That is y is equal to 0. It is the equation of x-axis. So find out this limit. We get limit x tends to 0. So put y is equal to 0 in the given function, x square into 0 divided by x square plus 0 bracket square. So obviously it is 0. Now consider next root. So write down, consider the limit along. Now let us take again some simple equation, y-axis. You can use any equation. This is just simple equation, x-axis and y-axis. It is the simple equation, y equal to 0 and x equal to 0. So equation of y-axis right here, that is y is equal to 0. So equation of y-axis is x equal to 0. So put x equal to 0 in the given function. So this is the limit. Limit y tends to 0. Now put x equal to 0, 0 into y raised to 4 divided by 0 plus y raised to 4 bracket square. So this is again 0. So see, we have found limit along first root, it is 0. Limit along second root, it is again 0. Now find out third root and get some different answer. Now see how to get third root by finding the maximum power. So see, first of all find out what is the maximum power for x in denominator. Now see what is the maximum power for x in denominator. X square, and this is the bracket square. X square bracket square. So x raised to 4, this is the maximum power for x in denominator. What is the maximum power? X square and bracket square. So x raised to 4, it is the maximum power. Now adjust this x raised to 4 in numerator. Now already there is x square, that means we have to take the path y raised to 4 equal to x square. See how to get third part. How to find out third part? By finding the maximum power. What is the maximum power? X square bracket square. So x raised to 4, it is the maximum power. So adjust this x raised to 4 in numerator. Now already there is x square. So we have to take this y raised to 4 equal to x square, means it becomes x raised to 4. So write down this part, write down. Consider the limit along, now this is our third path, y raised to 4 is equal to x square. So use this third path. So we get limit x tends to 0, x square into x square, put y raised to 4 equal to x square upon x square plus, again put this y raised to 4 equal to x square, and this is bracket square. So this is equal to limit x tends to 0, x square into x square, this is x raised to 4, x square plus x square, this is 2x square and its whole square. So this is equal to limit x tends to 0, x raised to 4, this 2x square bracket square means this is 4x raised to 4. So x raised to 4, x raised to 4 cancel. So what is our limit? 1 upon 4, it is the limit. So see, we have found limit along first equation, it is 0. We have found limit along y-axis, it is again 0. But limit along this third path, y raised to 4 equal to x square, it is some different value and it is 1 by 4. So the limits are different, the 0 and 1 by 4, they are the different values. So the limits are different along two different paths, so it is called limit does not exist. So write down therefore, just write down below, therefore limits along different paths are different. So write down therefore limit does not exist. Write down next example. Write down solve the limit xy tends to 0, 0 of the function x raised to 4 upon x raised to 4 plus y raised to 4 minus x. So again the method is same. Okay, consider different path and find out some different answer. So write down the solution directly. So write down the solution. Consider limit along x-axis. Equation of x-axis is, write down, that is y is equal to 0. This is the equation of x-axis. So we use this first path y equal to 0, that is x-axis. So put y is equal to 0. So we get limit x tends to 0, x raised to 4 upon x raised to 4 and put y equal to 0. So this is 0 minus x. So solve this limit. This is limit x tends to 0, x raised to 4 upon x raised to 4 minus x. Cancel x throughout. So this is limit x tends to 0. So this is x cube. Cancel x. So this is again x cube minus 1. So solve this limit by putting x equal to 0. So this is 0 upon 0 minus 1. So this is 0. So what is our first limit? Limit along x-axis, we have found this as a 0. Now find out the next root, which is again the simple root. Find out limit along y-axis. So write down, consider the limit along y-axis, and equation of y-axis, write down, that is x equal to 0. So find out this limit. This is limit y tends to 0. Put x equal to 0. This is 0 upon 0 plus y raised to 4 minus 0. Put x equal to 0 in the given function. So obviously it is again 0. So limit along first root, we have found out limit along y-axis, it is 0. Consider second root as a y-axis, we have found out limit along y-axis, it is again 0. Now what is the third step? Find out some different root and get some different limit other than 0. Previously we get 0, limit along x-axis 0, limit along y-axis 0. That means we required here some different limit. Now see how to get third root. Now see what is our given function. Our function is x raised to 4 divided by x raised to 4 plus y raised to 4 minus x. Now suppose if we consider some similar equation, x square y square divided by x square y square plus y minus x bracket square. Now see, these are the same equation. What is the uniqueness between these two examples? So see, we have found out limit along x-axis, we have found this as a 0. We have found limit along y-axis, this is again 0. Now we have to find out third simple root so as to get some different answer. This is the technique for showing the limit 0. So see how to get third path. So see, observe these two functions. What is the given function? X raised to 4 upon x raised to 4 plus y raised to 4 minus x. This is again similar function. So see what is our observation. This one of the term from numerator and denominator, it is same. So this is the identification. One term from numerator and denominator, it is same. Now if we cancel this remaining term, what is the uniqueness? One term from numerator and denominator, it is same. So if we cancel this remaining term, then we get x raised to 4 upon x raised to 4, that is 1. So limit along third path, it is 1. So we can say that the limits are different. So we can say that limit does not exist. So see how to get this third root. This is some typical function. Okay, one term from numerator and denominator, it is same. X raised to 4 and x raised to 4. This first term from numerator and denominator, it is same. Now if we cancel this remaining term, so how to cancel the remaining term? If we consider the path y raised to 4 equal to x. If we take suppose path y raised to 4 equal to x, then x get cancelled. That means we get x raised to 4 upon x raised to 4, it is 1. So choose this path. So write down, consider the limit along the path y raised to 4 is equal to x. So put y raised to 4 equal to x in the given function. So this is limit x tends to 0, x raised to 4 upon x raised to 4. Put this value y raised to 4 equal to x minus x. So x get cancelled. This limit x tends to 0. So what is the remaining term? X raised to 4 divided by x raised to 4, which is 1. So what is our observation? Okay, limit along first root, it is 0. Limit along second root, it is 0. And what is limit along third root? It is some different value. So limits are different along different path. So we can say that limit does not exist. So write down, therefore, write down the conclusion. Limits along different paths are different. So write down, therefore, limit does not exist. So this is the technique for showing the limit does not exist. What is the technique? Choose different path, choose different equation and get some different limit. So write down the next example. Write down the similar example, solve. Now you can solve this example. Limit xy tends to 0, 0. This is the function x square y square upon x square plus y square plus y minus x bracket square. So write down the same solution. So write down the solution. What is the technique? Choose some different path and get some different equation. So this is the technique only. So write down the solution. Consider the limit along x-axis, that is y equal to 0. This is the equation of x-axis. So put y is equal to 0. We get limit x tends to 0, x square into 0, put y is equal to 0, x square into 0, put y is equal to 0 minus x bracket square. So obviously it is 0. X square into 0, anything into 0, it is again 0. Find out the next limit along some different path. So we choose this path. So write down. Consider the limit along y-axis, and equation of y-axis is x equal to 0. So write down that is x equal to 0. So put x equal to 0 in the given function. So this is limit y tends to 0. This is 0 into y square, 0 into y square plus y minus 0 bracket square. So this is again 0. So see, again we get the same condition. Okay, limit along first root it is 0. Limit along second root it is again 0. This is the repetition. We don't require the repetition. So find out third root and get some different limit. It is called limit does not exist. Now see, this is again the same function. Previous function it is again the same. Okay, one term from numerator and denominator it is same. So remaining term. What is the similarity for this function? Okay, one term from numerator and denominator it is same. So anyhow cancel this remaining term. So how to cancel this remaining term? If we put y equal to x. If we take this y equal to x, then x get cancelled, we get value as 1. So write down the next part. Consider the limit along the path y is equal to x. So put y is equal to x in the given function. So this limit x tends to 0. This is x square. Now put y is equal to x. So this is x square. X square, again put y is equal to x, and this x minus x bracket square. So this is equal to limit x tends to 0. Now x square into x square, this is x raised to 4. X square into x square, this is x raised to 4, and x minus x, this is 0. So we get limit x tends to 0, this is x raised to 4 upon x raised to 4 get cancelled. So this is equal to 1. So what is our observation? Okay, limit along first root it is 0. Limit along second root it is again 0, but limit along third root it is some different value. So what is our conclusion? Okay, limits along different paths are different. therefore limit does not exist. So write down, therefore limits along different paths are different. So if the limits are different, it is called limit does not exist. Thank you.